Yeah.
Great stuff. Thank you for all you do there, Chad. It's very much appreciated by the community. And I just want to tell people about what's going on today. This is day 2 of ClueCon. We've got a very full program. We've come off the back of an amazing collection of things yesterday, had all sorts of workshops and talk going on, and all sorts of fun in the evening with that Quiplash game that we were playing online and live in the lounge as well. Today we've got amazing workshops and talks to come across the whole day, including workshops from Janice and Homer, and more from Signal Wire and Free Switch. And we've also got talks from various different people. Răzvan and Bogdan are going to be back in, and our friend Lorenzo Miniero will be coming up before too long. But first up, a subject that I know is dear to a lot of people's hearts, WebRTC. Troubleshooting and debugging is often an issue, and Chad and Balazs are here with their talk, and we're looking forward to seeing what you have to say. So can I hand over to you, gents, and say thank you very much.
Great, thanks, David. As you mentioned, we're going to talk a little bit about WebRTC statistics, troubleshooting, and an open source project we worked on to try to figure some of this stuff out. But I guess maybe before I start, just quick intro. I'm a product consultant and blogger. Hopefully many of you read WebRTC Hacks, or if you care about WebRTC, hopefully you do. I have another blog where I look at AI and RTC topics at Coggate AI. And Balazs?
Yeah, my name is Balazs Kreith, and I'm working for Whereby as a WebRTC engineer. And yeah, I'm the lead architect of this open source project. It's not a big position, as we are just 4 people in the group. So, but yeah.
So maybe before we get in too deep, I do want to talk about where at least I use WebRTC analysis and monitoring, and as I'm sure many of you, the pandemics and real-time communication is pretty busy, and certainly troubleshooting, debugging, monitoring are all essential parts of any service. And I found myself, increasingly needing a flexible tool to help with a bunch of different problems. Like, one client, was trying to debug user media errors, and they're in the middle of switching CPaaS platforms, which made things a lot more complicated. Another one was trying to run some, another ran into some user-side performance issues after a Jitsi Meet upgrade. Another one, kind of a different domain, but was doing some regression analysis and wanted to do a before and after comparison while they were tweaking their, the WebRTC stack that they had on an embedded device. And so these are all, pretty, diverse types of problems. And to fix these issues, I usually like to start with tools that are already built in. And fortunately, WebRTC has an extensive set of stats built already via the GetStats API. And these stats actually come direct from the WebRTC stack itself. And actually, I think maybe I'll switch and actually show you some of this. Change my screen share quickly. So I mentioned the stats. If you ever want, in the spec for the stats, if you ever want some bedtime reading material, I strongly recommend this. It'll definitely put you to sleep pretty quick. As you can see here, it's pretty extensive. What I think is a little more interesting is most of all the major browsers have some internal WebRTC debugging and analysis tools. And these are great. So, Firefox has About WebRTC, there's Edge WebRTC internals, I'm using Chrome WebRTC internals. And here, and most of this actually pulls from that GetStats. It actually grabs a lot of really useful, nice data. And you can do this at any time, at least within your browser, to check this stuff out and get some nice, some charts and nice stats here. But what happens if you actually want to, this is all helpful if you're actually sitting in front of the browser and having a problem on your computer or your browser. What if you have some end user issue? Well, there you usually end up going, you want to take advantage of the stats API itself, right? So I'll just show a quick example of what this looks like. When I do this, right? So I just call the GetStats API here, and I dumped out a report, and you can see there's even more information than we showed in that in the internal screen here. And this is actually quite a bit. And the initial reaction might be, well, actually, it looks like there's everything you might ever want to need is in this. Why don't you actually just take all this, send it over some sort of, some channel, dump it into a database and do some analysis of it. But in looking at that, you quickly see like this is a lot of data, right? So this one report here is 23 kilobytes. And if I do the math right, it's 23 kilobytes. Say we did this at once every second, that comes out to something like 180 kilobits per second, right? And you're talking about the size of a video stream at that point. So it's actually a lot of data. So you can't just take this stuff and send it and hope you can figure it out later. It's a little more complicated than that. Now I'll turn this off. Go back to the slides. So even more than that, there's a lot of things actually GetStats doesn't tell you without doing more work out of the box. I mean, the metrics themselves are actually very raw. So for example, if you wanted to get bit rates, like you need to actually go add up all the bit rate stats and set your timestamps and then do the math yourself. And it ends up being a lot of work. And let alone it doesn't give you any of the statistical averages or peaks and that sort of thing. And if you want to actually compare values over time or across users, then you need to have some sort of aggregation function. And then the really interesting questions that you want to answer, like how did adding a new turn server impact the average quality of experience for users on like the West Coast? That sort of thing requires a lot more complicated analysis across these sub-reports and over time. So as obvious, these answers to these questions was going to take a lot more than just WebRTC internals or pull some GetStats queries. So actually 4 of us got together to work on this as part of an open source project that we ended up calling ObserveRTC. So Balazs is here going to talk about it a little bit more. Also thanks to Palab, maybe you can wave and say hi, and Benoit out there too. But with that, maybe Balazs, I'll let you talk about the project a little bit more.
Or at least I will. So there are challenges, and thanks to chat, there are challenges evaluating metrics for WebRTC calls, and I am using the term calls because that's a bit different than WebRTC stats. As I'm going to mention later, that WebRTC stats doesn't contain everything, even if it contains lots of data, it doesn't contain everything to tell you the full story, what's going on in the client side and in the calls. So one of the challenges is relies on the data itself. We have a massive amount of data and we need to analyze all of them, or we need to store at least all of them. And another challenge is that the number of participants is not linearly correlated to the number of stats, it's exponentially correlated sometimes. So this is the time when we say that we are in the era of big data and we need to store it in some kind of data warehouses, or we need to use something. But we decided that, okay, let's design an open source application which is integrated to everywhere in the data warehouses where you can analyze your calls and can be used in the industry. So one of the principles we had is that do not reinvent the wheel. Next slide. So we wanted to design an open source project which is capable of collecting WebRTC stats and other important metrics from the clients and forwarding into the data warehouses. Meanwhile, on the fly, it is capable of analyzing the calls. So one of the requirements, it needs to be forwarding in the data warehouses, and there are lots of data warehouses on the market, like Snowflake, Google BigQuery, or Amazon Redshift. So instead of designing our own, it needs to be integrated with the existing one. The next requirement was that on the fly, it needs to be exposing metrics. For that, we also want to exposing metrics like the Prometheus. Then we can send it to Amplitude, Metabase. There are tons of already provided solutions in the market, so we want to be integrated with that. And at that point, if we designing an application, we could say that, okay, we are done. But the problem was that we don't want to lose samples. And samples or WebRTC calls, the more WebRTC calls is happening on the daylight, and there are some restrictions on the data warehouses, how much samples you can actually insert over time. So that's limiting, by the way, the application itself. And then it eventually comes that if you don't want to lose samples on the daylight when lots of the WebRTC calls you have, you need to queue them in your application. Sorry? So
I think it was just
at that point we realized that we need a kind of message system, and then one part of the solution needs to be capable of receiving the samples, exposing metrics on the fly, and then another part of the solution needs to forwarding into data warehouses. So we started using Apache Kafka, which is a well-known message broker system between the two parts of the solution. There are other solutions exist, like Amazon Kinesis we can use. We can also integrate it with that. Currently, we using Apache Kafka. And from the beginning, we wanted to be able to deploy it into the cloud. So we used Kubernetes or Docker. And for that, we are using Helm chart. So the application is horizontally scalable. And finally, there is one more thing that if you are running several instances, then you need to share data in between the instances. For instance, if you want to determine on the fly which peer connection belongs to which cause, so grouping the peer connections, you necessarily need to share information from one instance running on the Kubernetes cluster with another instance. Either you are using a database, or in this solution, we find it an in-memory data grid is adequate for that problem. So altogether, putting it all together, we started to building this open source project. And yeah, so ObserveRTC, the aim of ObserveRTC is to providing open source solution to monitor and analyze your WebRTC calls. There are two parts of the solution. One is the client part called ObserverJS, and it is designed and implemented by PalabGain just to make sure that the query is going in the right direction. And this is designed to be a lightweight client library using shared workers also to send the WebRTC starts and samples. And the responsibility of that is collect and send samples. Now, instead of sending WebRTC starts and sending that user media, we multiplexed all of the information into one sample, called peer connection sample. And that peer connection sample is sent periodically to the backend. The client library is integrated currently with TalkBox Media, Soup, and Jitsi, and we are planning to integrate it with more. The backend solution is to monitor and analyze the samples written in Java, and it is designed to be scalable from a single local development to large Kubernetes cluster. And currently, it's integrated with Kafka, BigQuery, and Prometheus. And we are planning to integrate it with Redshift pretty soon. Yeah, so the full data flow of the current solution we have, that the client library is extracting the WebRTC stats from the client, and also the client informations like the operation system and the platform details. It multiplexes it into one sample, and that one sample is sent to the backend, where the observer receives it through a WebSocket. The observer is lying in a Kubernetes cluster right now, demultiplexing the sample and then exposing metrics to Prometheus and forwarding the demultiplex samples into Kafka, where from Kafka, an application called Observer Connector consume it, forwarding it to the integrated data warehouse. Now, from from the BigQuery or Redshift or whatever data warehouse you are using and integrated into a connector, you can analyze it with your favorite user interfaces like Grafana, Colab, Jupyter, or Data Studio, or whatever you want to use. That's up to you. And yeah, this is basically what we have right now for the data flow. So the schema, the demultiplexed sample is corresponding to a table in the data warehouses. Right now, the guessless derivatives is like ice candidate pairs, ice local candidates, and so on. They are in different tables, and there are browser details, and there are also aggregations, like Chad mentioned in the beginning, that we need for know what's going on. They are in the backend for further analysis in the later on. And yeah.
Oops. So yeah, thanks, Balazs. Balazs went through how this is put together. Unfortunately, actually, a lot of it's pretty easy to deploy. I'm certainly not a Kubernetes Docker expert, but I was able to follow the instructions and get this set up. But really, I guess what I cared the most about actually is the output, right? Trying to help my customers and others to deal with their problems. So maybe I'll show just real quick, show some of the outputs so you get an idea. Change my screen share again. All right, so Balazs mentioned that we have, we're hooked into Grafana for operations reports and kind of day-to-day monitoring. And really, Grafana is a great tool. We can plug this in, and this is we're just putting together our demo data set, but this gives you an idea here. Really, where I actually found the most value is in doing some more of the detailed, the non-day-to-day reports and kind of going deeper and doing more thorough analysis. One of my favorite tools for doing that actually is Jupyter, in Python. This Colab where we have this right now is just basically a hosted version of a Jupyter notebook. Jupyter notebooks are great. I mean, they're used a lot, and by data scientists, especially because it lets you actually run queries, do analysis. You can actually run Python code, and also just putting comments in here. And then on top of that, the Colab actually pulls in a lot of the same types of Google Docs features where you can comment and kind of at people and keep track of things and changes over time. So this ends up being a nice interactive document, which is really helpful when you're trying to collaborate with a team to uncover and diagnose an issue. As I'll show here, I mean, the general report, there's set up some basic parameters. You don't necessarily even need to know Python or a lot of this to follow it and tweak some of the things. And here it's all pretty straightforward. And you can see we're building out a library of kind of common queries. And every time you look and analyze something, we'll add it here. But you basically run your query, you put this in, and end up getting a table and some of the outputs. And you can do some charts and customize this. This is really helpful if you're doing some investigation and you want to tweak that input or that output. You can just go in and you modify your query and run that and change your charts, right? And you can see using this, you can find anomalies, issues. Like here's one example where I was looking at number of trying to diagnose the excess peer connections, and you can see that certainly happens. The average number of peer connections per call per day had a huge spike in this one server this one day. So I guess that that gives an idea. Maybe I'll switch back to the deck now. So just, I guess, summarize, I guess, what we've learned so far in the project is, first, it's great that it is based on Kubernetes, and we really want it to be a scalable system. And this works well, but it definitely, especially early on, before we actually had enough volume that needed to scale, it did add some overhead and extra work. It's starting to pay off now, but definitely was some upfront investment. Another area that was a kind of common frustration is that we started out with the idea that making pretty looking charts and graphs would be pretty easy to do once you had the data. And there's a lot of tools out there that do that, but we found that making those pretty graphs over time, I guess when you're dealing with data changes and swapping out surfaces and different needs, actually ended up being way more time consuming than it should be, and it continues to be kind of a frustrating area. And a lot of this actually does come down to the underlying data schema. So as Balazs mentioned, we do have a kind of a unified sample report that we're using, and we're working to simplify and improve both the input, what that report looks like, and some of the aggregations to make this easier. But it still does take some expertise to make sense of like what stats to use and what they mean. And probably as it comes no surprise for those out there, which the audience is writes open source code and uses it, no one really likes to do documentation. We've got a pretty good start there, but it's pretty tough to maintain. We have some more work to do there. And I guess the last thing we've learned recently is that when you run a cloud service that ingests a lot of data and when you run a lot of queries, you really need to pay attention to your cloud service budget. We found it isn't too hard to add thousands of dollars to your bill if you're playing around and you don't if you're not paying attention, or if you're not careful. And not looking at that. So that's the project. If you're interested in getting involved, either as a user, you want to go install and run this yourself, or we definitely would love to have other contributors help out. The repos there, just at GitHub, observe RTC. The starting docs, the link there also. And even if you don't want to go and run this up, we are looking for say if you want to just run and analyze and make use of our hosted infrastructure, we could probably work out something there too. So please feel free to contact us. And with that, I guess we can take any questions. Danny, Dave, I don't know if you want to take questions from the audience or what we need to do here, but I think they disappeared.
Yeah.
All right. Well, does anybody in the audience have any questions? I think anyone here can unmute themselves.
We're still here. Just phased.
Yeah.
Yeah. Hi.
What are some of the common browser problems that you're seeing? As far as what are some of the common
a question on common browser problems? I experienced this a lot myself, but it's I say the number one first thing is actually get user media kind of device access issues, and it varies a lot by platform. But there's a lot going on, especially when you're running in a web browser, trying to get access just to the camera and microphone. In particular, I have like a number of virtual devices and real ones in there, and a lot of times it picks the wrong one, or you have a conflict between, say, Zoom or Teams or some other application that's running in the background that happens to kind of grab the camera. And sometimes I think this is it looks like it's at the operating system level, where the operating system just doesn't give access to the camera at the browser, right? And as a browser application, there's not a whole lot you can do about that other than prompt the user and tell them, hey, do you have something else running, or are you sure your camera works, that sort of thing.
Right, apologies, I dropped out and I'm back in now. Thank you very much, Chad. Much appreciated. Were there any further questions? If people want to raise their hand, we can unmute you.
Yeah, David, there's a question in the chat.
Yeah, I'm afraid I can't see that because I got out and then back in. Do you want to read it out, please, Sharon?
Yep. How does your project compare to other open source monitoring projects?
Well, maybe I'll start, and Balazs, you can comment. I guess for monitoring for open source stuff, there's not a whole lot. I do think certainly like Hepic, Homer, that sort of stuff. And those are, well, one, this project is WebRTC only, right? And this is focused on the connection between the browser and, ultimately it'll be for mobile WebRTC clients too. But between the browser and the infrastructure, there's no kind of signaling or SIP analysis or anything on what we do. So we're really focused on those issues and pulling, basically using the client side stats and making sense of that. There is another, project, one of my WebRTC hacks partner, Fippo, put together called RTC Stats that does some of this, and that's more of a, and that's been somewhat taken over by Jitsi and focused on that, and not really, it seems to be mostly active there, but that doesesn't have like the Kafka and the stream management and some of the plugins that we've been working on for like Google Colab and other pieces there. But that, that's certainly another option.
Great, thank you for dealing with that one, Chad. I noticed there was a comment in the chat from Dan saying, great stuff, or that's amazing, or that's excellent, something along those lines. And it's very heartwarming that you've made this an open source project. We thank you for it.
Yeah, it'd be, I don't know, for me, it'd feel weird if we did it any other way, I guess. It belongs to be open source first. So.
Well, that's great.
I see in the chat that Dan said that I hate get stats. Well, no one really likes it, but that's only we have. So.
Well, it sounds like you guys have actually created a solution for the problem of people that hate get stats, because they can get on the other end of your solution now.
David, I've sorted out my mic. So yeah, I do hate get stats from a API perspective. And I've always said to the people involved that it should be easy. You can do complicated stuff, but you should also be able to do simple stuff without a maths degree. And this helps people like me who don't like doing lots and lots of maths get access to those statistics, right? Because someone that actually knows maths has done all the hard work for me.
Yeah. Yeah.
That sounds like a massive vote of thanks.
Yeah, well, yeah, we'll talk more, Dan.
Great. Okay. Any more questions for Chad or Balazs before we move on to our next speaker? Okay. In that case, gents, thank you very, very much for coming in and telling us about the project and giving us the details of how to get involved, both from a contribution and a user point of view. Really appreciate it. Chad, quick question on Cranky Geek. How's that looking for this year?
I think we're definitely going to do something like ClueCon. We actually might end up doing 2 events. So we're looking at potentially doing one like kind of April, May timeframe. So the event went really well last year, and we want to keep it relatively short. So I think we're going to break it up into a likely a May event and a November event like we do every year. Maybe they'll be in person in November, but we're not really counting on it. So right now we're planning for a virtual event in November. But if that changes, great. But again, we're planning for a virtual one. Okay,
thanks. Thank you for the update. And once again, Chad and Balazs, thank you very much for coming along. All the best to you. And
thanks for having us.
You're very, very welcome.
Always a pleasure.
And we'll bring up our next speaker. It's young Lorenzo. He's looking extremely young today. How are you doing, Lorenzo?
I'm fine. How about you?
Yeah,
really
very well. Very well. Very well.
Yeah, indeed. I shaved my beard. I look probably 2 weeks younger. So anything that I can take advantage of is fine.
Well, you're still a very young gentleman, Lorenzo. We don't want to cast you in an old light at this stage. But let me move on and ask you, because as well as Janice and Janice Con, you've also had VoIP on the Beach as well. So you're another event organizer. Any updates in that domain before we crack on?
Yeah, we would really. I mean, unfortunately, the second edition of JanusCon didn't happen because of the pandemic, and because we were very busy on other things, we didn't manage to find some time to organize a virtual edition like ClueCon and ComCon and others. So we really want to do a new one, possibly even virtually soon. But first, some wheels will have to stop moving a bit so that we can relax on some other things, because we are a very small team and we really can do too many things at the same time. But we really want it to happen again because we loved the first edition, and I really love the way ClueCon is happening as well, and it happened in August. So this really makes me want to do a new edition of JanusCon as well soon.
Great. Okay. Well, thanks for that update. Before we move on to your talk, I do need to tell people that we are still giving away a $100 Amazon gift card. People or the person at the end of this session, after Lorenzo and then after Răzvan and Bogdan, will be selected at random. But I hear you can increase your random chances by keeping your video on. So the more we see of your face, the higher the chances of winning that Amazon gift card. Now, Lorenzo, thank you very much for everything you do and the gift that you've given to the world with your team of Janus. What are you going to talk to us about today?
Yeah, today I'll be talking a bit about a more recent effort that I've been working on, which is mostly related to NDI, which is a technology that is not much known in our industry, but is very widespread in the broadcasters industry instead. And I actually did a small demo at the last ClueCon as well. I'll touch it briefly. And Dan is in the room as well. We've been working together on trying to make this a bit more accessible to everyone as well. So this will be mostly what I'll be talking about.
Great. Okay. Well, we're on the edge of our seats, looking forward to that. And so over to you, Lorenzo.
Thank you. So yeah, as I was saying, this talk will be about NDI and more importantly, how to bridge the gap between WebRTC and NDI. And so before proceeding, just a few words about me. I got my PhD at the University of Naples a few years ago, and I'm one of the co-founders of Meetecho, a small company based in the south of Italy. And some of you may know me as the main author of Janus, and here you can find some links about me and some of my hobbies. And Meetecho is a small company that basically works a lot on consulting and other things, mostly revolving around Janus. And we are all based in this beautiful city that you see here. I wish it were as sunny as it is in this picture right now. Actually, it was snowing for the first time in probably 50 years or something like this a few days ago, but it's still a really nice place to be stuck in a pandemic nevertheless. So I really can't complain. And when I'm mentioning NDI, some of you may have already heard about it, because I actually did a dangerous demo on this at the last ClueCon in August. And here you can see a screenshot of that, where we had 5 or 6 people joining an online conference that I had set up. And then I had basically another instance pulling those streams from the public service, and then basically generating the NDI feeds so that I could play with them in OBS, which is a popular broadcasting tool. And basically that very quick demo is a summary of what I'll try also to describe here as well. So I basically will try to describe a bit the process that led to that demo and everything that happened since, because of course that was just a quick prototype and we wanted something that was much more robust instead. But before moving on, of course, we need to first of all understand what NDI is. And first of all, you need to understand that NDI is a tool that is mostly used in the broadcasters industry. And when I say broadcasting, I mean TV shows and things like this. So anytime you see a talk show or a news show or anything like this, there's probably a big team behind there of media producers that are actually pulling media from different sources, typically from their own LAN and so on, so that they can design and combine anything that eventually happens on the screen. And NDI is a popular technology for that, because it basically allows you to pull different sources even though they are not physically connected to the machine that you are using. For instance, you have a file on a server that you want to pull and use as some stock video in a news feed, for instance, or you want to use some other media like that. And NDI makes this all easier. And first of all, NDI is a short term for network device interface, and is a royalty-free standard developed by a company called Meetecho. And this is a link where you can find some more information. And basically, as I was saying, it works by exchanging multimedia streams on the same LAN. And typically, it makes use of multicast DNS for service discovery. So you can figure out where a specific stream is, for instance, and then pull it that way. And it's actually relatively easy to use because there is a native SDK that makes it easy to build new applications on top of that, which is exactly what I use in my own effort, as I'll explain shortly. There are also some efforts to work on open source alternatives to that, even though they are a bit more, let's say, in early stages. And most importantly, there are a lot of applications that can use NDI for different use cases. So even, for instance, just by looking at the store of your phone, you'll find applications that you consume, for instance, NDI streams, so that it makes it very easy to produce and consume NDI streams in a broadcasting environment. Which leads to the next point, which is why are broadcasters not taking advantage of WebRTC to do whatever they need to do, especially in this time and age? And this was actually something that Dan himself asked himself about a year ago, and he was pointing out that, for instance, BBC News used Zoom a lot for the remote interviews rather than using, for instance, WebRTC, which seemed like an obvious choice. And Sam, in this case, explained basically why, which was broadcasters use NDI a lot, and there isn't an easy way to use WebRTC with that. And for instance, that Skype is used much more often in that case because at the time Skype did write a simple Skype to NDI kind of thing that allowed you to have conversations on Skype and then get NDI streams out of that, even though with some limitations, which is basically what led me to decide to start investigating this technology in the first place. And then the discussion proceeded a bit also in terms of what can we do with OBS out of the box, because there is an effort to have WebRTC support in OBS, even though in that case it's mostly for WebRTC out, not in. So it's basically to allow WebRTC to generate WebRTC streams rather than consume WebRTC streams and use them in turn by itself, let's say. And BBC News was, of course, not the only instance here, because I noticed the same pattern as well. Because, for instance, Bill Burr is one of my favorite comedians. So when I saw that ugly Cisco WebEx logo over his interview at Jimmy Kimmel, that really hurt my feelings. And even worse, when I saw, I like Conan a lot as well. And so when I noticed that his remote interviews are done via Zoom as well, that hurt my feelings even more. So that was possibly one more reason to start and investigate if there was any easy way to bring WebRTC in the picture instead, rather than these proprietary applications. And actually, a much more interesting use case, especially among us, is the ComCon virtual edition that took place in the summer, which Dan took care of. And most importantly, Dan wanted for his event to have pre-recorded talks because he wanted a much stronger focus on quality itself. He wanted more control on the post-processing part and so on, mostly to basically keep up on the standards that he had for the previous ComCon editions. And so the idea would be that speakers would still present via WebRTC, so you would basically get together with Dan and the production team in a WebRTC session so that you could present, possibly do several takes if you did any mistakes and so on. And then once everything was ready, the media production could then take care of processing everything that was recorded, which worked, but per Dan's word was also a bit of a painful process, mostly because, first of all, they had to use basically multiple applications together to get the job done. I don't remember exactly the details, but I think it was Jitsi for screen sharing and vMix for receiving the audio and video streams. And this is because vMix is one of those applications, one of those proprietary frameworks that can support WebRTC and can generate NDI streams, even though they generate mixed streams, which was a bit more cumbersome for the media team to handle, let's say. Which basically, yeah, as I was saying, on one hand you had vMix just doing the mixed streams. On another hand, you had multiple applications doing WebRTC, which could get confusing. For instance, you would start sending your audio in both applications at the same time, generating echo and so on and so forth. So eventually it worked. The result was great, but it took more effort than it would really have needed. Which is why Dan and the production team really started asking themselves, isn't there any easier way to do a plain WebRTC to NDI translation. So something where I just publish one or more streams, and then I get exactly the same number of streams as NDI instead, and then I can just focus on the composition rather than struggling with the tool that should actually help me. And so I started looking into this. First of all, looking at whether or not there were existing open source effort for that. And I mentioned, for instance, the libNDI library by VLC, which is still very much in its early stages. Another interesting effort is the GStreamer NDI plugin, mostly because GStreamer is very popular in any form of multimedia processing. And unfortunately, this tool can only be used currently to receive NDI streams and not to generate anything, which means that it wouldn't be helpful in this specific instance where we want to receive WebRTC streams and send NDI streams instead, on the other hand. So I still ended up using this tool for validation, especially in the early stages, as I shall show in the next few slides. But it wasn't something that I could use for the purpose, which means that basically I had to try and tackle this challenge myself. And basically what I started to do was focusing on a very simple RTP to NDI application. So I started focusing on something very basic. So how can I receive an RTP stream, possibly an audio and video RTP stream, and translate that to an NDI feed? And from a diagram perspective, it works pretty much like this. You receive a set of RTP packets, you recognize whether they are audio or video, you depacketize them as you usually do in any kind of media server, and then you decode them using the codec that you need. And then in this case, using the NDI SDK, I basically made sure that any frame that I decoded using, for instance, libopus for audio and libbaby codec using the right video codec for video, I would get a raw frame that I could translate to an NDI frame instead, and then send it via the NDI SDK as well, which eventually led to this very simple application that I called RTP to NDI, which I tested in a very simple way by having a GStreamer pipeline generating RTP packets, an audio-video RTP stream encoded pretty much the same way a WebRTC stream would be. This RTP to NDI would receive these packets, and then I would generate an NDI stream to see whether or not it was working. And basically, the tool was very simple. I basically configured it so that it would bind to a couple of different ports and address the string by which you wanted to be identified in NDI. I would start a GStreamer pipeline to send media to those ports. In my application, I would decode these streams, and then I would use the GStreamer NDI plugin to display the NDI stream that I was generating, just to basically verify whether or not what I was doing was actually working. And luckily it was. In this case, I was sending a pre-recorded SNL fake commercial just for the fun of it. And in this case, this window that you see was actually the NDI stream that was being translated by my small application. And of course, this was interesting as a first effort, but what I really wanted to do was not do plain RTP to NDI, but do WebRTC to NDI. And which meant that, of course, I had to start thinking about how to do that. And the first idea was, why not simply use RTP forwarders? And if you don't know what RTP forwarders are, it's basically a simple way that we have in Janus to take a WebRTC stream and relay it as a plain RTP stream somewhere else. And actually, my workshop in a couple of hours will be focused exactly on this feature if you're interested in more. So I encourage you to attend that if you want to learn a bit more about that. And in this case, so using, for instance, Video Room plus RTP forwarders plus this tool would have brought me closer to the target, but it was not really what I wanted to do. So I wanted something a bit more integrated, mostly because I didn't want to focus too much on the integration here. And besides, the decoding and NDI translates are lightweight enough that they can be done in Janus itself without heavy weighing too much on the operations that Janus needs to do, typically because we tend to avoid transcoding in Janus itself. And eventually this turned out to be a relatively straightforward process, mostly because Janus has its own RTP stack, so I didn't need the RTP stack that I created for the RTP to NDI tool. And then everything else worked pretty much the same way, which means that if we look at the diagram that I described before, I basically just needed to change a few things in order to make it work as a custom Janus plugin instead. In this case, you can see a instead of an RTP stream, we have a WebRTC stream getting to Janus, and then Janus passes the packets that it receives via WebRTC to the NDI plugin, which then can recognize whether or not it's audio or video packets. Basically, the NDI plugin is notified via a callback about any RTP packet it receives, and then everything else works exactly the same way. So I depacketize, decode, and then send via NDI. With the difference that here the approach is a bit more integrated. So as part of the Janus API, I can, for instance, address the NDI label that I want to use and things like this. Which means that eventually it became something like this. So a user sending a WebRTC stream to Janus, and then Janus itself via the NDI plugin sending an NDI stream to the production room. And so to give this a test, I basically created a very simple web page where I could basically publish a WebRTC stream to Janus, also specify the label that I wanted to use for the NDI stream, and then basically the end result was basically the same. So still using the NDI plugin, the GStreamer NDI plugin, I could display the stream that I was publishing via a browser instead. So this was, again, one step closer to the target, but not really there, because there was still one last part missing. So first, I was doing all of this in my own LAN, so in my own private network, which works for a demo, but not really if you want to make this globally accessible. So if I wanted to have a chat, for instance, with David online somewhere, and then pull those streams and turn them into NDI streams, I cannot bring David in the Janus installed in my own local environment. So I might do that, but it's a bit more problematic because, I mean, there's firewalls involved. It's hard to make Janus reachable. It's much easier to have a public instance somewhere where you can have the public conversation and then somehow pull those streams into your own local network in order to use those NDMs locally instead. And there are a couple of options that we could do here. So we could translate the code once more so that we could basically translate these to a client that would basically pull those streams from the Janus instance, or we could just leave exactly as it was and basically use Janus as a programmable client instead. And that is exactly what I ended up doing. So basically I started from this, and then I translated this to this instead, where we basically have a public Janus instance where you have the conversation happening. So in this case, this is where people connect to have the chat with each other, and they are chatting over the cloud, let's say. And then we have another Janus instance where the NDI plugin lives. So all we had to do was basically create some sort of an orchestration layer in here from a signaling perspective that would connect to this public instance as a fake participant, let's say, be notified about any person that was joining, and then anytime somebody joined, basically make sure that we could subscribe from here to here in order to receive the WebRTC streams from these other participants instead. In this case, this Janus instance is acting as a fake participant that receives all media streams exactly as a real participant does. And so since WebRTC is used, and basically two Janus instances can talk to each other because they are two-peer in the WebRTC communication, the end result is that in our own LAN environment, we have access to all the WebRTC streams that are connected to this public room instead. And since we have access to those streams, we can translate them to NDI because everything is done locally in this case, and then generate the streams that we needed. And in order to give this a try, especially when I first wanted to experiment with this, I experimented a bit with the streaming plugin. So the streaming plugin is basically a simple way we have where we send a plain RTP stream to Janus, and Janus turns this into a WebRTC broadcast. So we have a demo always online on the Janus demos where we have an always available WebRTC video stream provided by the streaming plugin. So the first thing that I wanted to check was, let's try to have my local Janus instance pull this remote stream from the public demo Janus instance, and let's see if I can visualize this via NDI as part of the process. If it works, then I'm done, and I basically just need to work on make it a bit more dynamic. And eventually, luckily, of course, it worked, and this is what I ended up displaying when I consumed that stream. So in this case, I was receiving the WebRTC stream from the public instance to my own local instance, and I was translating it to an NDI stream locally that I could consume. And which basically meant that we were done from an architectural perspective, and this is also basically the first step that led then to start thinking of whether or not this could be made more accessible to end users, and basically his idea for Broadcaster VC. And he actually announced it a few weeks ago and is now in beta. And basically, it's basically a collaboration between Dan and us, and the approach is pretty much the one that I've described in the previous slide. So the idea was to have a hosted infrastructure that would take care of the public conversation part. So imagine a conversation service provided as a service, in this case by Nimble Ape, which is a pool of public Janus instances that you can use for the conversation part. So, for instance, the interview or your podcast or whatever. And then you have a Docker image that instead contains a Janus instance plus the NDI plugin that you spawn in your own network instead. And using some automagic orchestration, you can basically have these Docker images automatically pull any streams that are being created and added to the rooms that you have control of. So let's say that you create a conference room because you want to have a public interview with a few people. You just need to configure this Docker image to subscribe to that room, and then anything that takes place in that room will be automatically received by this Docker image and then automatically translated to a set of NDI feeds that you can consume locally. So as you see, much simpler than for any producer or broadcaster, because all they need to do is take care of the conversation part, and then everything else is done for them automatically. They just need to consume the NDI feeds. And this is basically working. So it is, as I was anticipating, in beta right now, and so you can already give this a try. I definitely encourage you to visit that link for more information. And the rest of my presentation will mostly be a short summary of the changes and announcements that we did since I got that first hack working. Because what I explained in my previous slides was basically what led to the demo that you saw at the latest ClueCon demo, ClueCon Dangerous demo, and so. But there were still things that we needed to do in order to make it work better. And first of all, for instance, we added support for stereo streams, because this was something that was much more, which was then suggested mostly because WebRTC does support stereo, and so having access to stereo streams in your own broadcasting environment can be quite helpful, which was relatively easy to do. Something that was a bit more tricky was fixing some artifacts that Dan was experiencing in his first attempts, which were mostly related to the fact that we didn't have a jitter buffer in the early prototype, and so we were just decoding in real time any packet that we were receiving, which, as you know, means that any out of order packet or missing packet would basically lead to this kind of artifacts taking place. And so inserting a jitter buffer there definitely helped fix this issue in the first place. Another trickier issue was related to some streams that were not really being displayed correctly. And actually, if you look closely at the recordings of the Dangerous demo I did at ClueCon, there was one there as well that I covered because I was ashamed. But basically, it turned out to be a quite silly problem. So it typically seemed to happen only for screen sharing most of the time. So typically weirder resolutions than the one that cameras typically have. And it was just basically some missing information that we were not setting in NDI frames, like stride and stuff like this, that are typically related to how you address some video frames before you shove them around. We also added support for some test patterns, so something that could be used easily to verify whether or not your instance works without the need of generating a WebRTC stream in the first place. So let's say you install the Janus Plus NDI plugin in your network and you want to check whether or not your producer setup will be able to consume NDI streams from Janus. This should be possible typically in the same LAN, but since MDNS is used for broadcasting, MDNS may or may not work depending on LAN fragmentation and segmentation and so on and so forth. So having some way to basically generate a test stream that you can consume even independently of whether or not anybody is sending WebRTC stream was actually helpful. And so we added something like this in a programmatic way. And in this screenshot, for instance, you see Dan was using an NDI viewer on his phone to basically verify whether or not his phone was actually able to consume the NDI stream that the Janus instance was generating. We added some support for watermarks as well. And this may seem like a, let's say, more silly requirement, because typically any kind of watermarking, lower thirds and so on, is typically done in the application, the broadcaster application itself. So it's something that you can easily do within OBS to craft the scene any way that you want. In this case, we wanted to add the way to also hard code the watermark on the video itself, possibly for branding requirements or anything like this. So in this case, this makes for an easy way to hard codes a specific image on the video stream itself so that it cannot be removed when you actually use it in the application itself. And to conclude, we also added, and this is very recent news, since we had already added AV1 support many months ago, but it only became available in browsers very recently. We wanted to check whether or not it would work with the NDI plugin as well. And basically, it turned out to be quite easy to depacketize AV1 and decode AV1 as well, which means that you can indeed use AV1 and the NDI plugin will be able to consume it anyway. And if you want to see all of this in action in a more, let's say, interesting way than just see me blabbering about it, first of all, there is a demo that Dan recorded a few weeks ago where he goes in detail about how you can actually go from zero to a working setup using Broadcaster VC. And this screenshot also shows a bit how it works. So in this case, a web page where you have your own communication, your own live interaction with the other participants, and then NDI streams becoming automatically available in the tool of your choice, in this case OBS, so that you can do your own composition and be creative with NDI feeds. And this is basically it. So I hope this wasn't too fast or too confusing, and it was interesting enough for you all. So if you have any question for me or even for Dan, because I know he's in the room, I'll be glad to answer them. Thank you.
That's great. Thank you very much, Lorenzo. We appreciate that. Lorenzo, please keep your screen share switched on, even though it's been taken off the screen. And can you put it back to the slide just before you talked about Broadcaster VC? There was a picture of a man and a woman on the screen there. In the meantime, while Lorenzo is doing that, any questions for Lorenzo? Okay. In that case, oh, is that somebody who's got? Is that Maxim with a question? Sobo Max.
Yeah, that's me. That's me, Dad. Hey, Lorenzo, nice.
Hey, Maxim.
Again. How are you? Question I have: how do you handle synchronization between streams and audio and video? Is there any problem with that, or is everything working without any concerns?
At the moment, we haven't focused too much on that, mostly because, especially when you are pulling a single stream, basically, in this case, the audio-video synchronization within the same peer connection is assumed to be pretty much there already. And so the moment you are consuming it, we are basically just translating it and converting it to NDI. When you have multiple peer connections at the same time, there may be a bit of of course, the desynchronization there, but we haven't noticed anything weird in that specific instance. And we don't expect there to be any specific problem that wouldn't happen in any regular web conferencing application that we typically attend. So because in that case, you are basically doing the same thing. You are receiving a lot of streams at the same time, and they may or may not be in sync. And so you have to consider the NDI recipient as pretty much another participant in this context. So exactly as something is happening in a real conference, you are translating it there. So I expect that producer tools like OBS are able to introduce some artificial delay in case they notice something that they may want to fix in real time as well. But in that case, that's something that can be taken care of at a media production level rather than at the media transport layer instead.
Thank you. Did that answer your question, Max?
Yes, thank you.
Great, that's good. Okay, before we carry on, I just, Casey, thanks for putting that screen share up in the middle again. Can you put it top left on a highlight 2, please? And in the picture next to it, can you pop Răzvan in, please? Just want to do a quick comparison there. I can't help thinking that there are some similarities.
You mean between the actor and Răzvan?
Exactly. I don't know if we're going to get that.
Hairstyle.
I've gone off script slightly here.
Yeah, I can see some similarities in the hair.
Yeah. If it doesn't work with me, try Bogdan.
Is there anything you want to tell us, Răzvan?
No, actually, I wasn't part of that commercial or whatever that was, but it does look like me.
Okay.
Or I look like him.
Thank you, Răzvan. Lorenzo, thank you very much for coming along and talking to us about that project. And
thank you for the opportunities. It's always nice to be here.
We're looking forward to your workshop as well, coming up a little bit later today. Top stuff. But for now, we're going to let you go in the interest of timing and move on. Lorenzo will be around, so if you do want to ask questions, you can find him in the chat or maybe in the cwh cafe or somewhere else like that. But in the meantime, thank you very much, Lorenzo. For bye for now, and we'll bring up Bogdan and Răzvan because they're coming up next. Fresh from a great workshop yesterday, where you had a nice number of people in attendance learning more about what's going on in the world of OpenSIPS. How are you feeling today, Bogdan?
First, thank you, David. Well, we do feel ready. Especially, I'm really positive all about this because actually Răzvan will be the main speaker today. So I'm really cool, just sitting and watching. So yeah, he will do the heavy lifting for today because the part that he's presenting, it's some work he did. So he will have the honor to present it.
Oh, well, that's great. We're very pleased to be having that information from you. Thank you again for your participation and for delivering that workshop yesterday. We really appreciate it. And for everything you do in the open source community. And of course, you have your own event called OpenSIPS that happens periodically. Any plans for that this year, Bogdan?
Definitely. I mean, that's a tradition for, I think, 6 or 7 years to have the OpenSIPS Summit. Last year, of course, as everyone else, we went online. With probably this year will be more or less the same. We haven't set yet a date. We are actually chatting with the guys today about this. Like, okay, we should start doing that. But yeah, definitely will be an OpenSIPS Summit this year.
Great. Something else to look forward to on the calendar then, as well as our ClueCon coming up in August. And of course, we'll be very pleased to have you take part in that again. But now let me hand over to you both and say thank you. And we're looking forward to see what you have to say.
Thank you, David.
Thank you, David. All right. So let's get started. Today, we will be discussing about how you can control media for ongoing calls using just a SIP proxy. And the main scope of this presentation would be to make the best out of the 2 projects that that are involved during this presentation, OpenSIPS and FreeSwitch. So let's get started. I bet most of you know what a SIP proxy is. It's a lightweight server that facilitates interaction between a set of SIP endpoints. Usually, a proxy has routing capabilities, right? So when Alice wants to call Bob, the proxy usually knows where Bob is, and it's able to reach Bob. However, normally, the RTP flows directly to between Alice and Bob. And this might become a problem because you can only rely on the capabilities in terms of media services. You can only rely on the capabilities of what the device have. If, for example, you want to add more enhanced media capabilities, since you don't have control to this RTP flow, you can't do much about it. So in order to add enhanced capabilities, you probably need to use a fully fledged media server B2B user agent, which will act as a SIP endpoint, but provides various media capabilities. So you're no longer limited to whatever the device supports, but you can also add your own capabilities. Let's see how a media server would fit in this scenario. So imagine that Alice wants to call Bob, but we also want to have some enhanced media capabilities. Instead of sending the call directly to Bob, we will send the call to a media server. The media server acts as a B2B UA, so it will start a new call saying from the media server to Bob, and OpenSIPS will send this call to Bob. As you can see here, the RTP flow does not go directly from Alice to Bob, but goes through the media server. And since we get the flow to the RTP to the media server, we have a lot of things that we can do with it. The problem with this setup is that, as you've seen earlier, you need to have two different separate calls, at least from OpenSIPS perspective. You have the inbound leg and the outbound leg. Sometimes if you want to match, for example, for CDRs, if you want to match those two calls, it might become harder. You'll have to add some markers. You will get two sets of CDRs for each in and call. You will also use twice as many resources because, for example, you have to create two different dialog structures. From the media server perspective, it will control both the calls and the signaling. And you probably know that processing RTP, it's quite resource intensive, especially because you have to do media handling. Even, for example, if you want to do transcoding, that's even worse. And probably you don't really want to do that. Most of the time, a call from A to B is just simple media proxy. You just pass along the RTP from one point to the other. So the question is, if you're not going to offer like enhanced media capability, does it worth to have all this overhead, two different calls, two different set of CDRs, just for the sake of probably some of the users might engage in some enhanced media capabilities? Or why not? Why can't we engage a media server during an ongoing call only when it's really needed? So only when we really need a specific media service, for example, playback. Playing back music on hold or what so. So that's how we came up with the media exchange module and media exchange functionalities in OpenSIPS. So the idea is that having a SIP proxied call, so a call that goes from A to B through OpenSIPS, that's it. What if we want to add some enhanced media capabilities? Well, this is what the module solves, and it basically is used to go or start a call to a media server only when it's really needed. So this is why it's very lightweight, because you don't really need to pin a call to a media server. For example, if during a call you want to play music on hold file, you can choose whatever media server you have available and is less loaded. So you don't really need to put all the calls in a media server, and you can do that because you only engage it when you need it. And the idea is quite simple. It basically mixes or swaps SDP's body between proxied and proxied calls and B2B calls. We will see how simple that is, but again, OpenSIPS doesn't do anything with media. All the media hard work is still done by the media server. such as phrase switch in this case. And the fun part is that you don't really need anything extra. You don't have any requirements on the user device, on the SIP device, or on the media server, because everything is full SIP compliant and you don't need any SIP extensions. It's pure SIP. Let's see how the idea comes from. So imagine that Alice wants to talk to Bob, and she will say, "Hey, Bob, where should I talk to you?" Well, Bob says, "Hey, Alice, if you want to talk to me, you should reach me at SDPB." However, since OpenSIPS or a proxy is in the middle, it can say, "Hey, Alice, I think you should talk to Carol. Hey, Carol, how can Alice reach you?" So the proxy, instead of saying Alice to talk to Bob, it will say, "Hey, Alice, talk to Carol." This way, the RTP flows between Alice and Carol, even though Alice thinks she talks to Bob. And if you think about this, this is exactly how the media relays work, such as RTP proxy or RTP engine. Is the exact same idea. You provide an SDP, the callee provides an SDP. However, each of them receive a different SDP that is managed by a media relay, in this case, RTP proxy and RTP engine. Let's see exactly how this works. So Alice sends OpenSIPS his own SDP. The SDP is describes where it should receive its media. And OpenSIPS says, "Hey, Bob, you should talk to A at SDP A." In response, Bob says, "Hey, Alice, you can reach me at SDP B," and Alice knows how to reach Bob. So at this point, we have established an RTP flow between Alice and Bob. So Alice and Bob can talk about their problems, whatever they want. But let's say at a certain point, you want to engage some enhanced media capabilities. For example, from the proxy side, you want to warn Alice, let's say, that it's running out of credit. It's just an example. What you would do from the OpenSIPS side, you will start a call saying, "Hey, play me back a file at SDPA." Note that this is not what Alice says, but it's what the proxy, what OpenSIPS says. Start a call with and send me RTP to this SDP. The media server will answer, offer his own RTP, and then instead of sending that to Bob or to Alice, we will tell Alice in the same dialogue, so in the same call, "Hey, Alice, if you want to talk to Bob, you should reach him at SDP MS, the SDP of the media server, right?" And at this point, we have established an RTP flow between the media server and Alice. Note that Bob will still send RTP to Alice. That's because he wasn't updated about any new SDP. So in order to fix this, since Bob is no longer involved in the call, because the call now, like from the media perspective, is between Alice and the media server, we have to put Bob on hold. So to do that, we will send an on-hold message to Bob. So the scenario is quite simple. Alice and Bob establish a call and they talk to each other. During the call, media server needs to, so at a certain point, we decide that we have to engage an enhanced media server. We will send a re-invite within the dialogue with the new media SDP. And to one of the participants, we can also send it to the other participant as well. We can, for example, start 2 different media services. We can play back something to the caller and something else to the callee, or for example, to the callee, we can ask him to prompt a pin or whatever. But if we only want to mangle one of the participants, we can put the other one on hold just to make sure that it won't continue sending traffic to the other participant. And when the media service terminates, the call is resumed just as a simple proxy call. So you don't really need to do anything else. This is the flow where Alice and Bob talk to each other through their own RTP flow. And OpenSIPS is able to both originate, or the media server can originate some traffic to and push, and OpenSIPS can push it toward an existing call. This is the example where OpenSIPS is the one that originates the call. So this is the classic scenario where Alice puts Bob on hold. OpenSIPS will send an invite to the media server. The media server provides its own SDP in the 200 OK. We send a re-invite to Alice containing the media server SDP. In reply, we get the 200 OK with SDP and establish a flow between Alice and Bob. In this case, since we don't want to have Bob involved, we will simply put it on hold, providing Alice's on hold SDP. And at this point, as you can see, the RTP between Alice and Bob disappears because Bob will no longer send it, will no longer send anything because he's on hold. A similar flow happens when the media server wants to originate a call. So again, we have a call between Alice and Bob, and the media server sends an invite with its own SDP saying, hey, push me an announcement to this call. What will happen? The same. We will send a re-invite to Alice, providing the media server SDP. We'll get the SDP back in the 200 OK, and we will forward that SDP to the media server. This is a bit more natural. That's because in the previous case, as you've seen, we were storing A's SDP, which might or might not change. So ideally, it should work like a challenge answer pattern where the media server challenges and Alice answers. However, in practice, most of the SDPs don't change over the call, so it's quite safe to do that. And even if it does change, it will re-invite in order to make sure that both parties are updated. So in practice, this works quite okay. And of course, we will put an RTP flow will be established between the media server and Alice, and Bob will be put on hold. This is a small description of how things work, and it's basically what I've presented you earlier. No point like revisiting them. In terms of requirements, there's not that much requirements. As I said, there's no SIP extension needed. It flows just on a regular SIP. From OpenSIPS side, you will have to use the dialog module, and that's because we use the dialog module to store SDPs and store some state information in order to be able to retrieve whether the call is on hold or not. You should also use the B2B entities module in order to intercept calls from media server or originate calls to media servers. This is the module in OpenSIPS that is able to provide B2B capabilities. And of course, you will require a media server such as FreeSwitch in order to play back announcement or offer whatever enhanced media services FreeSwitch has to offer. And it does have to offer a lot. So you will definitely need a media server. A similar functionality is the media forking, which its purpose is to copy media from a call to a different SIP endpoint. But in order to do that, we need to get access to the media flow or to the RTP flow. And that's why we need RTP proxy or RTP engine. That's why we need the media proxy in order to be able to hook up in the media flow. And once we do that, we can ask the media relay to forward the RTP to a different destination. Unfortunately, actually, luckily, RTP proxy does provide these capabilities for like more than 10 years, I think. The sad part is that the other ones are not quite providing it right now, but who knows, they might do that. You will see that this is mostly inspired from the way the CBREC module works in OpenSIPS. So it's basically the same idea, although you can use this, for example, to listen to a call or to record the call, but without using the CBREC payload. How this works, so imagine that we have a call between Alice and Bob that goes through RTP proxy. And at a certain point, Carol comes to say and say, hey, I want to listen to Alice's conversation. So what it will do, it will send an invite to OpenSIPS, providing its own SDP. And OpenSIPS will absorb that invite, and it will inform our proxy to copy the media stream that flows between Alice and Bob, copy it to Carol. It will provide a new SDP that will be sent back to Carol, and a unidirectional RTP flow from the RTP proxy to Carol. And note that this is only unidirectional because RTP proxy will not be able to inject a real-time RTP flow in a call. Of course, it can play back files and stuff like that, but it doesn't work the other way around. Perhaps now that Maxim is listening, perhaps he will want to do that. So the idea behind media forking scenario is that when Alice and Bob establish a call and somebody wants to listen to a conversation, OpenSIPS will create a call, or it can also originate or receive a call. And OpenSIPS will instruct RTP proxy to fork the RTP to that SDP so that the third-party user can hear the conversation between the two. Of course, listening can be paused, resumed, or terminated. Unfortunately, there are a couple of limitations. For example, as I said earlier, the RTP is unidirectional. You can only listen to what the other participant talks, but you can't talk because we are not injecting any RTP in any real-time RTP during the call. You can currently have one single listeners, although this might have changed. I'm not sure. Maxim could confirm that. But anyway, both OpenSIPS and RTP proxy need to work around the solution to be able to have more listeners, so to be able to accept more participants listening to a conversation. This way, we could perhaps offer some sort of a unidirectional conference, let's say. There's no transcoding or no codec negotiation involved. So during the third call, you'll have to use the codecs that were being used in the initial call. And it's not compatible with DTLS or any SRTP. That's because keys are negotiated between the initial participants of the call. So a third participant will not be able to pop in and negotiate his own keys. Now let's see a couple of examples about what the media exchange module can do. So as I said earlier, one of the use cases is to listen a call where we have a call between Alice and Bob that goes through OpenSIPS and RTP goes through RTP proxy. Carol calls in and says, hey, I want to listen to one of the participants. And RTP proxy will start forking the RTP of one of the participants to Carol. Whenever a byte comes in, this flow stops, and as you can see, the call resumes to its original state. Let's say you want to play some music on hold. Okay, you can do that. Whenever Alice puts Bob on hold, it will send a re-invite with a special marker, A equals send only, saying, hey, I want to to put Bob on hold. But instead of sending the reinvite to Bob, what we'll do, we will start a new call to the media server saying, hey, play back some music on hold to this SDP. We will get an SDP, we will get our call answered, and we will send this SDP in a reinvite to Bob. So instead of sending A's on hold SDP, we will send the media server's SDP to Bob. What will happen is that Alice no longer sends RTP, or should no longer send RTP because he's on hold. So this RTP flow disappears, and the new RTP flow is established between the media server and Bob. Whenever the call gets resumed, Alice will send a new reinvite with his plain SDP, so without the A equals send only marker. We will send a byte to the media server and then simply relay the reinvite to Bob, reestablishing the flow just as it was before. See that this call no longer exists. The RTP flow no longer exists. Basically, there's no more reference to this media server. If you, for example, want to put the call on hold again, you might as well choose a different media server, because it's this one. It's basically idle. A different use case is call whisper. So again, we have a call between Alice and Bob where that flows to OpenSIPS, and we have a third party, let's say Carol, that wants to whisper something to Alice. It will start a call to OpenSIPS. OpenSIPS will reinvite Alice, providing Carol's SDP, and put Bob on hold in order to make this RTP flow pause. And at this point, we have established a call between Alice and Carol. Actually, an RTP flow, because as you've seen, there are actually two calls. It's this call and half of this one. In order to terminate this call, Carol terminates the conversation with Alice, sends a bye. OpenSIPS reinvites Alice, this time with Bob's SDP. And it will reinvite Bob with Alice's SDP. And of course, this RTP flow finishes and is resumed between Alice and Bob. Again, we resumed our call to the initial state. And also, a very nice feature is the call bar chain. So we have two different, let's say we have a customer and an agent talking to each other without using anything extra, just going like a regular call. And at a certain point, Carol decides that he wants to barge in. He wants to make a conference between all three participants. What will happen? It will send a call to OpenSIPS. And instead of contacting Alice and Bob, it will start a conference room to the media server, or to Freesich, for example. And at this point, Carol is in a conference room of the media server. Then OpenSIPS will start. Actually, this should have been the other way around. Then the media server starts a new call to OpenSIPS saying, hey, invite Alice in this conf room. And what OpenSIPS will do, instead of starting a new call, it will reinvite the existing call with the conference's SDP. And this will end up in putting Alice only as Alice's RTP in the conf room. And OpenSIPS will start another call saying, hey, also add Bob in the conference room, adding a third RTP flow to the conf room. So at this, all three participants are talking to the media server. It's just Carol Carol is actually that has a call directly to the media server. All the others are Alice thinks he's talking to Bob. In order to resume, basically we terminate these calls, the calls to Carol's call, the calls to the media server, and re-invite Alice and Bob with their original SDPs, and this will resume the call just as it was before. So without having any media server involved, without starting any new calls, without having a third or fourth call for the conference. All these features are already available, so they have been released in the media exchange module in OpenSIPS 3.1. You can play with some configuration files that I used during the OpenSIPS Summit demonstration. So you can use this repo in order to play with this setup. And you can also find a blog that I wrote a while back that describes how the media exchange module can be used to achieve whatever. Thank you so much for your attention. Let me know if you have any questions, or if we do have time for any questions.
I see Giovanni has raised a hand there. Giovanni, would you like to ask a question? We'll just have the one question before we go to break, and then we'll leave the room open for people to ask you more questions. But go ahead, Giovanni.
I'll try to be very fast. So at least in the barging use case, this seems similar to how you can use the UAC send sequential, and as to send a reinvite that are inside the dialogue and just change the SDP.
That's exactly what it's doing internally. Actually, for all the scenarios, basically what we are doing, we are just sending reinvites inside the dialogue, but mangling the SDP. So we're not offering an SDP of that call, but the SDP of a different call. So we're just playing around with SDPs in different calls in order to make participants think that they are talking to the same person, let's say.
So those are utility functions like wrappers around send sequential.
Yes, well, there's a lot of logic for mixing SDPs and keeping states, making sure that you don't reinvite somebody that you shouldn't, or you don't. Perfect. But yeah, it's essentially some wrappers around the send sequential module. Yeah.
Okay. Yeah. Thank you for that observation, Giovanni. I'm going to move things on. What we're going to do is we're going to go across to Abby. Thank you very, very much, Răzvan and Bogdan. If you'll please stick around in the room after Abby's told us about what's going on, and also given away a $100 gift card, an Amazon gift card. When we've done that, we'll open things up in the break for questions. We are going to come back on time, so we're going to come back at 11:30 Central when we've got another two great speakers coming to talk to us about various things. There'll be Diego Gosma. He talks about AI, and in particular going to be looking at sentiment analysis this time around, I think. And then, of course, we've got Dan Christian Bogos, both of these people, friends of ClueCon, just like Răzvan and Bogdan, and they'll be itching to go in just over 15 minutes' time. But for now, thank you, Bogdan. Thank you, Răzvan. And we'll bring up Abby. Abby, what do you got to talk to us about right now?
Hi, everyone. So excited to be here on the second day of the second ClueCon, the first ever February ClueCon. We've got some really cool workshops coming up. This time, the workshops are at the end of the day, starting at 1 p.m. Central, where we'll see Lorenzo again with his Janus workshop. We also have a Homer workshop and a free switch workshop. You can see the full schedule at cwh.consulting, but those are at 1, 2:30, and 4 p.m. Central. So I'm really looking forward to seeing all of your wonderful faces there. Of course, I do have $100 to give away, but it is ClueCon ClueCon tradition for me to stall and put that off until the end of my announcements so that everyone pays attention. So welcome to the ClueCon tradition. I'll be talking a little bit more about the coder games today at 12:30, so catch that. And we're also going to be hanging out in the lounge after all the workshops are over. So of course, all the rooms that you see on that home screen and in the room navigator are open for everybody to explore. So feel free to hang out in that coffee shop or the lounge whenever you want. But we're all going to be meeting in there at 5 o'clock Central Time if you guys want to come out and chat with us. We also have a SignalWire concierge room open. That's a special room. If you have any questions about SignalWire in general, or any questions about the platform that we're using specifically, SignalWire events, our sales team will be notified anytime anyone enters the SignalWire concierge room, and they'll be there to chat. And if you just want to say hi, they'll be down for that too. So SignalWire concierge room.
Abby, let me just jump in for a moment because I saw it in operation earlier. I was just looking at the room navigator and I saw somebody go into the SignalWire concierge, and I was just about to go in there myself and say hello when Ryan showed up, one of our salespeople. So it happens very fast. You only need to drop in and somebody will come along and say hello to you.
Oh yes, they're ready. We have it rigged so it'll notify them anytime anyone enters the room. No one will be notified if you enter the lounge, so no worries. But the Ryan is on it. He's waiting to talk to you. He's a little lonely today, so he's excited to talk to everyone. All right, and with that, I do believe it's time to announce our 100 card winner. We have one more after this, so drum roll, bell roll. Cue the bell. And the winner of our $100 gift card is Tim Fry from DNS Network.
Tim Fry.
Congratulations, Tim Fry. Again, for those of you who are in this conference right now, you're automatically entered into our random drawing. But, we do give a little bit of bonus points to those who are showing their camera. And congratulations to Tim. Thank you for joining us today. And congratulations on your beautiful prize.
And Tim, check out the chat for instructions to claim.
Second. I have you check that. Excellent. Thank you, David.
Okay, that went a little bit juddery for me just there. Maybe it's the Brazilian broadband. Who knows? Okay. Thank you, Sharon. And thank you, Abby. We're going to go for a break now. We're going to be, everybody's going to be around, I expect. So if you want to talk to anybody, stick around. Razvan and Bogdan are in here as well. Thank you very much, and Abby. We'll see you again a little bit later on. But for now, we're into a break, and then we'll be coming out at 11:30 Central. So just 13 minutes time when we'll be hearing from Diego Gosmar first.
Yay.
See you soon.
Great. And I do